worry about that later, and we're going to get to that later. So based off of that video, is there anything that you guys might want to know more about throughout the unit? Because I will definitely incorporate anything that you guys want to know about matrices so that you guys are just as interested as I want you to be. Is anybody curious as to why you can't divide matrices? It's kind of weird. We might talk about that a little bit. We will be doing adding and multiplying matrices. We will do multiplication of matrices. We'll also multiply by a scalar. And we are going to do the encoding and decoding part of the lesson. And we'll do some fun activities with that, so it's not just boring math all the time. There you go. So, obviously, this is what I want you guys to do for today. Our goal is that we're going to define matrix vocabulary, so things like matrix, equal matrices, dimensions, rows, columns, figure out things like that. And then from there, we're going to create matrices from word problems and use those matrices to answer questions. So I know you guys do not like word problems, but I promise it won't be that bad. And there's actually a point to everything that we're doing for your real life. So let's go on to the next part. Based off of that video, does anybody have an idea or want to share and save their fellow students from being picked randomly using the sticks? Does anybody want to share what they think a matrix is? All right. So we'll go ahead and go to the sticks. And don't be afraid, I just want to hear what you guys have to say. So, Kenna, there you are. All right, so what do you think a matrix is?
I couldn't tell you.
What did it look like in the video?
It looked like a square that has 4 numbers in it.
Okay, so in the video there was a square and there were some numbers in it, and in the video itself they had square matrices, which we'll talk about. So if we're talking about what a matrix is, we're talking about a rectangular array or set of variables or constants that are in horizontal rows and vertical columns, and then you saw those brackets in the video, so they have those weird brackets around them. So usually you'll be able to tell what a matrix is because of those brackets. When we want to describe a matrix, we're going to describe it using dimensions. So we haven't really talked about what dimensions are yet, so I'll do an example of that in a second, but we're going to describe it using dimensions, and we're going to call it an M by N, or say rows, number of rows, by number of columns. So if we go down to this matrix example right here, we call a matrix based off of the variable. So looking at this one, this would be matrix A, and then this one would be matrix B. So you just call it based off of the variables. Now I said that we're going to call things based off of its dimensions. We're going to describe the matrices based off of its dimensions. So all that means is you go to this and I say, how many rows does matrix A have? So how many rows does matrix A have? 3. So 3 rows by, and then how many columns does it have? 4. So if I told you I want you to describe matrix A, all you would say is 3 by 4. Or write 3 and then the X 4. How would you describe matrix B? 5 by 3. So we have 5 rows, 3 columns, so it would be a 5 by 3 matrix. Now here's another thing. We have these numbers that are in here, and they're not just called numbers. In science, you guys have the periodic table, and you have all the different elements that make up what the universe is. So in this case, you could think of the matrix like the universe, and these are the elements that make up our matrix. So each of these variables or constants are called elements. And then along with that, if I said I want you guys to tell me what element A sub 21 is, match up your variable here with whatever matrix it is. So my variable is A. Match it up with matrix A. This number right here, this 2, tells me I'm going to go to the second row. So I'll go down to the second row. And then this number tells me what column I'm going to go in. So I would go second row, first column, 5. Make sense? Okay. Now, if we go down to the next part, we can talk about equal matrices. So, equal matrices are basically exactly what they sound like. They are equal. However, they do not just have the same dimensions, they're going to have equal elements. So I could not just put up here another 3x4 matrix and say I have equal matrices. My 3x4 matrix would have to have those exact same numbers within the matrix in order for them to be equal matrices. So elements are the same and they have the same dimensions. And then the last one is a square matrix. And that's kind of what we saw in the video, what you were talking about, kind of, is having a matrix with the same number of rows and columns. So just how a square has equal sides all around, matrix has equal rows, equal columns, it'll look like a square. You could also have something called a row matrix. So if I was to stand over here and I made these 2 rows right here, I made these a matrix, and I just took this front row right here, this would be a row matrix because I just have a row, I don't have columns. Same idea if I went to each of these and I split you guys from your elbow buddy, I would just have a column matrix. So pretty intuitive as to what it sounds like. If you have a square matrix, equal all the way around, same number of rows and columns. Column matrix, just one column. Row matrix, just one row. Questions? All right, I know I said a lot of words, and I did not do a lot of examples. So let's do some examples and make sure we're all on the same page. How would you describe matrix A? 4x3. So I heard 3x4, which is okay because I make that mistake too because it's kind of intuitive to just go across and down. But you want to do the number of rows and the number of columns. So 4x3. And how would you describe matrix B? 2x4. So now, I mentioned this earlier, and if you're in the back and can't see, it's okay because I will say these out loud. Can someone tell me what element B sub 23 is? Who said it? How'd you get that? So you're saying down 2 over 3. I want us to not say down 2. I want us to say second row. Because sometimes I can think, I'm going down 1, going down another 1. So we're going to say second row, but you are right. Second row, third element, 7. So that one would be 7. And what about A sub 32? Zero. And then let's just do a couple more, because I think you guys got this. What about A sub 42? 2. And B sub 14? 0. What if I told you, this will work, there we go. What if I told you that I wanted you to find A sub 53? What's A sub 53? That's right, it's nothing. There is not anything there. So we don't have a fifth row. So if you get something like this, usually the question that's asking you, it'll say if it doesn't exist, write impossible or does not exist or something like that. Just because I don't want to write out impossible, I'm just going to write does not exist. Because there is no fifth row, so there is no third column of a non-existent fifth row. Questions on those? All right. So now we have the dreaded word problems. And I know you guys absolutely adore word problems. I completely understand. Let's look at this one. Carl is looking for a laundromat. Superwash has 20 small washers, 10 large washers, and 20 dryers. Quick Clean has 40 small washers, 5 large washers, and 50 dryers. Tough Suds has 15 small washers, 40 large washers, and 100 dryers. Write a matrix to organize this information. All right. Who thinks they could write a matrix to organize that information right now? Without me telling you exactly what to do. How would you do it, Peewit?
Well, I would just put a 20, well, first I would draw brackets.
Okay. Good first step. Draw brackets.
Okay, and then I would put a 20 for small washers.
Okay.
And then over from that, 10 large washers. And then over from that, 20 dryers. And then I would put 40 under the 20, 5 under the 10, 40 under the 20.
It's 50. It's okay.
50,
You're good. I know you can't see that well.
and then 15, 40, and 100.
Good job. So how'd you figure that out?
I just use my noggin.
Just used your noggin. Okay. So did you think about it maybe like a table at all? Were you kind of thinking like organizing it in the rows and the columns like a table? It's essentially what a matrix is. In a matrix, we are taking this information. Think about putting it in a table, but when we're doing a matrix, we just take those numbers from that table, put it between some brackets, and now we can do some work with this. So in this case, her column right here, each column represents small washers, large washers, and dryers. And then each of her rows represents one of the different laundromats. So same idea as doing a table, we just don't have the labels. I don't know if I want to do, we're not going to do that one. I think you guys are good. All right, here's another one. So a store manager records the number of light bulbs in stock for 3 different brands over a 5-day period. The manager decides to make a matrix of this information. Each row represents a different brand, and each column represents a different day. The entry in column N represents the inventories at the beginning of day N. Once again, word problem. Real wordy because they like to do a little introduction. So all we can do is we could just go through and see, all right, this is what I need to know. I need to know what each row represents, what each column represents, and what each entry represents. So what does each row represent? Brand. So just like writing a table, I'll just go through and I'll just say B1, B2, and B3. That way we can keep track of which one we're looking at. Since we didn't write the matrix ourselves, we're given this, so we'll figure out what we need to do by writing the headers and the side part. What does each column represent? Different day. So D1, D2, D3, D4, and D5. All right, so now we're actually going to do some stuff with this. I know this looks kind of overwhelming, but what I want us to figure out is I want us to figure out the daily differences in the inventory. So if I take one of these elements right here, if I took 22, that means for brand 2 on day 4, I have 22 light bulbs in inventory. So if I started with 25 and now I have 22, that difference of 3 means what? If I'm a store manager, I started with 25, the next day I have 22. What happened to those 3? What did I do with them? Sold them. So we're going to figure out how many each brand is selling over a period of days. So from day 1 to day 2, how many did brand 1 sell? 1. And then day 2 to day 3? Day 3 to day 4? And day 4 to day 5. And what about for brand 2, from day 1 to day 2? Day 2 to day 3. Day 3 to day 4. And day 4 to day 5. And then the last one, day 1 to day 2 is day 2 to day 3. Day 3 to day 4. And then none for the last one. So now looking at that, can you tell me which brand holds a record for the most number of light bulbs sold on a certain day? Brand 3. Why do you say brand 3? There you go. So, pretty easy. Just looking at these numbers, figure out which one is bigger. You all okay over there? Okay. Figure out the biggest number, and then you can say which one holds a quote-unquote record for selling the most light bulbs. Which store sold the most, or which brand sold the most light bulbs overall for all 5 days? Which ones?
2 and 3.
2 and 3. So if it's a little hard for you to see, that's okay. It's all good. So brand 2, they sold 9 light bulbs, and brand 3, they also sold 9 light bulbs. So brands 2 and 3 both sold the same amount of light bulbs over the entire week, or the 5 days. Does anyone have any questions about that one? All right, we'll do another one. All right, I think this is our last one that we're going to do together. So a shoe store manager keeps track of the amount of money made by each of 3 salespeople for each day of a work week. And then it goes through and it tells us what money they made on Monday through Friday for Carla, John, and Mary. So Dalton, how would I set this up in a matrix?
You put 40, and then underneath it you put a 70, 35, 15, 20.
Okay. So I'll just go ahead and draw brackets first, just so we have that. So, and then keep going. Same thing. And then the same thing over here. If you guys want to keep talking and not paying attention, I can just keep having us do problems in class, and you will actually do your homework for homework rather than having an extraordinary amount of time to do it in class with a possibility for bonus points on your homework. So if you want to keep talking, you can do that, and we'll just keep doing problems until the end of class. So, we done? Okay. So, Dalton, you said that we're going to set it up this way. So the way Dalton did it was he went by people, right? So your columns, the tops of your columns are people. So Carla is this row, John is this row, and Mary is that row. So I'll just write Carla, John, Mary. What do each of the rows represent? Days. So Monday, Tuesday, Wednesday, Thursday, and Friday. If I had this matrix, could I have done it a different direction? Could I have, instead of having a what's the dimensions of this one, how would I describe this matrix? 5 by 3. Could I have a 3 by 5 matrix instead? Yes. So it doesn't matter the direction as long as your numbers are in the right place on all of them. All right, now I want you guys to tell me who made the most money over the course of the week, Carla, John, or Mary. So you can get your calculators out or you can do it in your head, whatever you need to do. But I want everyone working on that. Which one? Did you add them up, or did you just do it based off of the numbers? Okay, so you added it in your head. So we have Mary. Does anyone know how much money Mary made? $225, I think. What about John, and what about Carla? And what about John? What's John?
Oh, Carla's 2.
That's unnecessary.
I think Carla said it was 2.
Carla is 215. Thanks. Sorry. I don't know why I put a decimal there. That was weird. All right. Does anyone know what John made?